Hi, I'm Jeff Beer from the Embedded Vision Alliance. I'm here at CES 2014 in Las Vegas, and I'm in the demo suite of the Alliance member company videantis. I'm here with Marco Jacobs and Mary Sue Haydt from videantis, and we're going to see some demos of some of the latest technology for embedded vision from videantis. So Marco, first of all, tell us a little bit about videantis. What does videantis do?
Sure. Welcome, Jeff, at CES here. videantis is a 10-year-old company. We'll be celebrating our 10-year-old anniversary. And what we have, our product is a very low-power, high-performance processor that we license to the semiconductor manufacturers. And the processor is especially good at video processing. And what we do is we do computer vision acceleration. So computer vision often uses a lot of compute cycles, a lot of energy. We ensure that you can take this to a low-power embedded device.
So this is silicon intellectual property for people to embed in custom chips?
Correct. Our business model is similar to ARM, where we license our hardware to the semiconductor manufacturers and they integrate it into the SoC.
And does videantis also provide software?
Yes, indeed. We provide a full solution of hardware, so our processor, together with optimized software for computer vision acceleration.
So customers of yours create a custom chip that includes the videantis processor, perhaps running some software supplied by videantis as well as some of their own software.
Correct. Yes, their own software will be a layer higher, so they can make function calls to an open vision, a computer vision algorithm, and then we do all the acceleration from there by running it on our own processor.
Okay, great. So what demos are you showing here at CES today?
Right, so we have many different demos here. We have our own board with a 40 nanometer silicon. We don't sell this chip, but this is just a test and development platform. And we have it connected here to an Android tablet, and we're showing how we can offload the processing on the tablet applications processor onto the board and accelerate it, make sure it's really low power.
So this is analogous to the way in an embedded system the videantis processor would offload a CPU, ARM or otherwise, handling the heavy-duty vision processing.
Exactly. Yes, so you should think of this processor that we have here just becomes a very small area of silicon inside the applications processor that's in the Android tablet.
Okay, and what's the motivation? Given that the CPUs, the embedded CPUs are getting very powerful now, we have Cortex A15, 2 gigahertz and so on. What's the motivation for having a specialized processor for vision?
Yeah, exactly. So indeed, the ARM and a GPU is quite powerful and provides quite good performance on vision. But the power is really a key issue. Exactly those speeds that you're talking about, 2 gigahertz plus, with very long pipelines, very complex processor that's really built for web browsing, running Java applications, etc., is not very good at doing video processing. So we have very short pipelines. We have our processor completely optimized for all this pixel processing, and that's why we can get to a factor of often 100 lower or 100 higher in performance and a factor of 1,000, 3 orders of magnitude lower in energy consumption.
Great. So what vision functions are you demoing today on the videantis hardware?
Yeah, so one thing we're showing here is, for instance, face detection. So we accelerate OpenCV, and OpenCV comes with a face detection, Viola-Jones-based algorithm. Yeah, so here we're showing feature detection. So feature detection is an algorithm that finds the interesting points in an image, like corners, for instance. And if you run this on an ARM or a host CPU, it has to touch all the pixels to find these interesting features, and that takes a lot of time. What we do is we offload all the pixel processing, find the features, and then forward that information back to the ARM again, such that the host CPU only has to work on a few hundred feature points instead of on a 2 megapixel image.
So you're tracking about 200 features in this case?
That's correct. It's about 200 features, but we certainly can go up if required.
And what's the resolution and frame rate of the video stream you're processing here?
Yeah, in this demonstration we use a 1280 by 720p camera, but we can certainly go higher up to full HD or even higher if required. Our processor can scale up to the performance required.
1280 by 720, in this case at 30 frames per second?
Correct. This here runs at full 30 frames per second at about 60% processor.
Okay, and so all of the pixel processing is done on a videantis engine, and then the feature information is being passed up to the host CPU?
Correct, yes.
And how much, roughly speaking, how much power consumption does it take to do that pixel processing on the videantis processor?
Yeah, so the power consumption is dependent, of course, on the exact process technology that you built your chip in. This is in a 40 nanometer LP process. So today, most mobile phone designs will be going to a 20 nanometer or even 60 nanometer process technology, and the energy consumption will shrink. But here we use about 10 milliwatts or so on this device to run this.
That's impressively low number for processing HD streaming video.
Yes, and that's exactly how we have to beat the host CPU or the GPU, is to beat them on power mainly. We see that always-on applications are becoming more important, and the camera will be on more often to see what's going on around the phone, and that's why power consumption is key.